So basically, this is just a demonstration, I suppose, or just something to put out there in relation to some of the work that I can do or that I have done, or just as an example for people to see if they need to. But initially, I would like to show you this, which ultimately shows who you're speaking to a specific degree. I would show like my idea or something, but I think that would be just a bit too much. Whereas this is much more simplified, and that's one of the reasons why I'm showing this, and another reason why I'm showing this is just to give an explanation around the context switching that's involved in this process. So moving from a security perspective back into a sort of work style perspective is quite difficult, and also working in different environments where we're utilizing different types of skills and things of that nature can be quite difficult. So working with infrastructure or cloud-based services only, as opposed to actually working with other specific technologies. But in this instance, my intention is just to demonstrate for people to have something to see regarding me, and also for me to express my understanding. Though I'm a bit tired in essence, it should be alright, because I haven't really had my sleep schedule has been a bit odd lately, but that shouldn't be too much of an issue. However, what we're going to do, we're just going to go over a deployment of a specific set of infrastructure, and there'll be a Git repository that you can also reference at a later point in time given your need to do so. So basically it was like it was a tech test that wasn't really ultimately catered to a degree, or at least it didn't really go as intended. So what I've then went and done is just basically filtered out all the information, or the identifying information. It wasn't really NDA based, and it was based on a few open source technologies. I won't really go on the scenario of the requirement of the test, but I sort of took a way longer route and done way more than I feel was ultimately intended. So I think it's okay to share it, because I think it goes way beyond what was actually expected. And I think I might spend much more time on it than intended, and it was pretty much open book, and the intention was to demonstrate my ability to do certain things. So what we have here, okay, so if just bring up that tree again here, just had to, okay, so we got the tree here, which just shows what the directory structure is like. So this is basically the directory structure. You can see here that we have a bunch of different things. We have in the top we have the Docker containers here, some cloud build stuff here, some Golang stuff, Kubernetes stuff, which was one of the main key things as well, was to demonstrate my understanding of Kubernetes. But also my intention was to actually go a little bit more into it, just to demonstrate also my working style and what my general intention is for most of these things, or at least how I hope to work, and what I'm ultimately looking for in my next organization. That was one of the key fundamental things here. So this is basically it. And this is basically it here. So those are some of the things that I intend or have an intention of demonstrating. So I think what would be important here, I think to actually go through what some of these things do, but what I think is necessary is, first off, let's just look at the make file here, which is a bunch of stuff. It's very messy and it's somewhat basic, but I can just explain what it pretty much does in general. It initializes the environment, which I don't think or feel that I need to do at this stage, since I'm doing this from my local machine and that's already configured. And then it uploads the function to a specially unique created bucket, and provisions that so that it's internally accessible to any sort of system that might need to utilize it within the cloud environment. And then here, now with do some edits, you might actually encounter errors when you try to perform this deployment. But regardless of that, so the make file actually enables us to orchestrate things. So here we have the order in which things are orchestrated. So there's an upload function, there's import containers, deploy ingress, in init push kube repo. And here we have the general order. So the upload function will upload the code. The deploy ingress will ultimately deploy the ingress container, and the init push kube will push code to a special Git repository that hosts the Kubernetes charts. Import containers will basically import containers, but only once after Terraform apply has run. And Terraform apply will basically spin up the infrastructure, and Terraform init will initialize directly the infrastructure is in. And basically what we have here is we have this deploy all over here, which will ultimately do things in that particular order, and again use this to orchestrate stuff in very unique ways. But it really takes a lot of thinking to get it right. It's not one of those things that's just easily doable as most people would assume. But I think that when you're starting with a fresh project, it's more difficult to actually put things into perspective, because you have to write everything pretty much from scratch, which makes it a bit more thingy. But in a team project, you're working with other people. If it's something that's sort of for a long term, you have enough time to sort of deduce and understand what it is you'd like to get out of it, in essence, right? So that's one of the key things. So here, what I intend to do, I'm just gonna run deploy all here, because I feel like the environment is already configured as intended. And I also just double check that again, just make sure. I see, here we go. The cloud projects needs to be configured, and we have reference to this here. Should be able to just take this from here. Rub that bit out there in a minute. So here we go, and then what we're gonna do, we're gonna just configure our cloud project here, which you can do by just edit paste. Since it's much simpler, this thing uses different types of buffers. Alright, cool. So we have that there. Cool. Alright, there's a bunch of comments there as well that you can look through if you want to. And like I said, it's definitely not the best. It could be done better, using shell scripts. So having shell scripts will make this so much more easier. Having one shell script that takes various inputs. I'll show you what that ultimately looks like. I have an example of that. So if I go to here, for example, Docker get images, you can see here that we have this shell script here that has a case statement there, and then with that case statement we can then reference what we basically want to have run. And here basically we're just gonna run the import containers command, which does a bunch of stuff there, but then we're gonna you can see here, if you look at the cloud build file, we call that with .getsh, and then we will perform an import, which is also pretty intriguing in essence. So then that import will get passed in as the first argument, and that's what you see here on the $1, and then that will run this import containers function, which will then import a bunch of containers and format them accordingly. So you see here we do a bunch of different things to tag and then push those containers. So if I do make deploy all, hopefully that should start the process, and then what I'll do is I will walk you through some of the code, some of the interesting bits of code, and yeah, and then hopefully you can get something meaningful from that. So I'm gonna hit make deploy all. So here's gonna create our it creates a storage bucket. It applies object viewer permissions for all authenticated users, and then it zips the Golang code, and then it ultimately uploads that to the bucket we just created, and then after that it then goes into the Terraform directory and then starts to begin the process there. It initializes it directly, which means that Terraform will fetch everything from the remote repository, providers, etc. And then once that's done, then there's ultimately a plan here that we can see. I think ultimately everything seems okay. I'm trying to think if there's anything that would be worrisome. Okay, so I want to check if the bucket we created is referenced for the cloud function, and yeah it is, so that's cool. Alright, that's fine. I think that's one of the main gotchas that I tend to have there. And yeah, I'm pretty comfortable with the way most of this looks. Cool. Alright, this looks okay, so I'm just gonna type yes there. And then Terraform is gonna start its process, which should ultimately be okay. So now Terraform is running the provisioning, which is just making API calls to the remote repository. So Terraform is just making calls to the remote repository, and then what we just want to do here, we just want to so Terraform is just making calls to the remote repository here, so it's going to be doing its stuff there. And then in the meantime, we can just take a look at some of the Terraform code. Basically, again, main file, pretty simple. We have our kubernetes compute in the data section, and then we output and an output there. One of the interesting things with the vars file, so if you look at the vars file here, you can see here there's a bunch of variables, so we can actually define variables. Yeah, so we can actually define a bunch of variables through the environment, which these are the ones that are supplied through the environment, and a bunch of other sort of basic information. And then we have the project file is not really relevant, it's just the two things, which is the Google beta and Google stable providers. Cool, so this is the alright, and then we're gonna just ls, so we're gonna look at compute, actually no, we're gonna look at kubenet. So here we have resource compute network, auto create false because we don't want to auto create anything. We reference that there, and like I said, like you know, here what we're doing is we're just having a secondary range, and because I was in a rush to get this out of the way, so I used one or two things. I was able to use the documentation, but where I wasn't, so it was mainly the cloud provider documentation, my knowledge and understanding and experience, etc. And also some Stack Overflow helped quite a bit. But I think that for me, my understanding of the importance, because I don't shame people for using Stack Overflow or for looking for answers in different places depending on the situation and the time frame that you have, because in some instances you might be comfortable with actually using man pages, right? So it depends on the situation and the environment, but I don't really shame people for that. So basically sometimes that I do that, but I have to have the correct knowledge and understanding regarding what it is that I'm looking at and truly understand it. And that's why I'm able to actually find it in the first place, because I know exactly what it is that I'm trying to find, right? Which is also a key. So that's one of the more important things. And then here basically we define a secondary range. We define a cube router because our instances are going to have IP addresses. So we define a cube router. And then that cube router has NAT, which will allow traffic to leave our network, and our instances won't have public addresses, which means that it will be safer and also cheaper as well, and also they can scale more because there is a limit Google places on free accounts and how much IP addresses they can have. And also I think that some things like looking at Stack Overflow, especially when working with cloud providers, can be really helpful in most instances, because that means that because you will encounter things that are just so weird and creepy and you ain't gonna really have anyone to ask. So in that scenario it would be best to just have like a reference output there. Again, you can see here that we have like a list, and then in that list there's a map, right? And for me, one of the things I had to find out was like how to extract this really quickly, and so I just looked at, I noticed this merge thing, which made me realize how to actually do that, which allows you to basically update the value while also ultimately providing that list map into the argument or into the parameter, which is pretty cool. But obviously, like I'm saying, you have to have knowledge to do that, and when you do find it, you have to know what the right answer that will yield the result that you're after is. It's not just about like I think people think that people undermine it sometimes. Okay, so here we go. We got alright. That's the kubenet, and then we have the compute, and the compute is pretty interesting. We have the GKE cluster deployment here. So here we do cube, we have location, network, subnetwork, network mode. We're trying out VPC native here, which means everything. So you don't have to have routes defined, because normally what happens is that between your pods have to understand how to route traffic to other nodes. In this instance, you don't actually have to configure any actual routing rules. So normally there'll be like routing rules regarding how to route between nodes. Yeah, that's correct. Unless you have an overlay. So the VPC native is a type of overlay, which I believe uses VXLAN, which is kind of like I forget about nowadays. So that's overlay. We supply the subnet network from the network module. Here we issue client certificate because we're going to require that later on. Here we just define the client cluster range and cluster service IP addresses, which was what we passed in as a secondary IP range there. But because we know the format of the naming convention, we can make that static basically in some instances. We have a node pool, we have a basic node config, we have an auto scaling configuration, which is also interesting. It helps in some instances, because even when I was deploying things, in some instances, not all instances, you might be expected to just auto scale it. So for example, if I had 4 zones, then I would generally have an extra bit of resources. So sometimes it's a resource thing, but for that you need to understand capacity planning, from my understanding on things. and then we have locals. Basically here I'm just defining the attributes for my kubeconfig file, which I'm gonna need for a bunch of different things, and I pass in information here to template file, the Kubernetes endpoint, which is the IP. I pass in this context thing, then I pass in the CA certificate, the client certificate, and the client key, right, which will enable me to authenticate, and then we render that, and yeah, and that's and then there's an output there of where's this service account. Yeah, service account is not actually here. That's gonna be in. So in the IAM look, right? Again, like I'm saying, it's rushed. It was just not even like, it's not like production, but like you know, we have like one service account, and we have these bindings here. But then again, at the same time, we have a, you know, we set the service account. We can always add more members if we want to, but these are very broad permissions, which aren't really necessary to be this broad. You can review the roles within GCP console or using the G Cloud tool, and there you can find roles with your desired with the permissions desired that are more refined, or you can create custom roles. And then here what we do is, so there when we add secret manager assessor, talk about that in a little bit. And then here we have a cloud build, which gives us the cloud build identity account, and then from then on we can, or the service account, and then we can take that service account and then add extra permissions to it here, because I wanted it to be able to do some extra stuff there, such as authenticating to clusters, getting cluster authentication. But again, you can refine that based on what you actually require or need for a particular thing. So that's that. So here we've got a kubeconf and then the serverless config. Here we've got vars tf, which basically a bunch of stuff that we input. The kubeconfig is interesting because basically this is the templates that's used. So basically you see here we take context, we reuse context a lot here, but we take server, which is the most important value, certificate authority data, users. Okay, client is the user that's created for the certificate that we get, client certificate data, and client and client key data. So that's pretty much it there for the kubeconfig. And then we'll look at the serverless is probably the one that's going to cause problems in the deployment most likely, even though I've checked it a couple of times. It always there's always issues here and there. So here we create a secret manager here with kubeconfig config, and then here we create the actual secret. So the secret version is where we pass in the secret version is where we actually pass in the data here. The secret version is where we actually pass in the data, which is actually quite relevant there. And then here we have the actual, so basically what we do is we take the kubeconfig and we store it in a secret in secret manager, which is just basically a secret storing mechanism that allows you to share secrets between different services, different GCP services, but not only that, it extends to other things as well. It extends to, you can use other clients like APIs to access it if you need to. So it's pretty much that. So the serverless function here is pretty interesting. So what you see the serverless function, we actually have increased it. No. Yeah, cool. Right. So with the serverless function here, you can see that we actually have the US Central 1 build config go 1.20 which is one of the key ones that we're using. We have an entry point which takes the function that should be called, or the function that should pretty much be run by our serverless service. I hate this because it's like well, so it's okay. The error messages you get from it are quite bizarre. So we have build config here. So when the build config here, like again, because it's like Cloud Run mainly, to be frankly honest, and then we have the storage source, which is where we get our containers from. But you can actually use source code, but I'm using storage because there's orchestration process issues between Terraform and the other services that we have there. Cool. And then we have service config, which sets out the like max instant count, because you can auto scale, right? Available memory, etc. Whether it serves traffic or not, you know, sometimes you can do weird type of deployments with this, which is not really what I'm doing in the present moment in time. And then we have service control, the service account, which is important for accessing specific information. And then here again, what we do is we make the secret that we created. We make the secret that we make the secret that we created. We make the secret that we created accessible to the mount path, which is mount cube, and then the project ID, and then the secret has cube config and the secret ID here. So the secret is made available to the running service, so we'll be able to then access the cube config file, which is key. Now, okay, so I think you can actually have multiple secret volumes as well, which is pretty interesting for serverless functions. So that's one of the key fundamental things. I've been memory issues there. Yeah, I think just because I'm tired. So yeah, so the secret there, cool. And then we have the event triggers. So basically we subscribe to a pub subtopic that we create here, and in our pub subtopic we're looking for published messages, and every time there's a published message to the pub subtopic we're subscribed to, it triggers our function, right? And our function will run. We'll look at our function in a little bit there. So that's pretty much that. We've looked at cube config, we looked at serverless vars. That's pretty much it. We can just really quickly look at the data section here. So we have the Artifactory containers, cube deployments, the length, services also, and the count. So this is basic Terraform really, but understanding that the power and extensibility of Terraform is one of the key things that really gives an engineer power, which is something that I always seek to demonstrate. So here is the services we have, and then the source repos that we're going to create. And because this is a list, the list is ordered. Some instances, where do you get an unordered list? Some languages you get like an unordered list or something, but this list is ordered, so you can always count on the various variables being in the same position for order. And then here we have the build. Can I make this? See the preferences here. I'm gonna We want zero terminal transparency for this actually, because no, it didn't. Yeah. Oh, sorry. Okay, there's a terminal is and then terminal and application both. Okay, cool. So here we actually have the so here we actually have we create pub subtopics again. We use length here for each repository that we have. We create a pub subtopic, and this is the format of the naming, and then we have also an extra pub subtopic here because I didn't want a repository for Docker in a sense. But these better data structures we can use. Yeah, I didn't ultimately want like this particular Docker repository to be in this fashion. And so here we have our build triggers. So every time there's a push to the repository, a build trigger is triggered, which then triggers a cloud build, right? Through this cloud build file, which has the instructions for that. It's a bit messy, let me tell you, because you're meant to use a lot of shell scripting when working with cloud build. Like you know, the way that I did it is kind of hacky, because again, like I said, there's a lot of context switching in this process, so please bear that in mind. And so we have one for deploying Kubernetes services, we have one for building containers. Those are the two main cloud build. I know there's a third one, there must be a third one. Okay, source repository. Here we create the repositories. And we're just gonna cut the vars again here. That was pretty much it for the cloud build. I thought that there was a few more. So here we create Docker files and Docker repo. And here we have for services we have monitoring and sock shop, right? Which is a common application that you will see out there. So yeah, so that's pretty much it really for the Terraform repository. And now we're gonna go look and see if our if our build runs successfully, which I evidently doubt. So that was are you sure? Was it Artifactory? Cool. With build triggers, there's only 2 build triggers. Is that correct? Yeah, which is weird. I thought there'd be more. Cool. All right, that's fine. And then all right, cool. So then we run into an issue here. So it's complaining about our function. Before I didn't actually have any errors with this, to be frankly honest. These errors actually crept in quite late. What does it mean init transport is undefined? Alright, cool. Let's just see if we can fix this here really quickly. And I hate when this happens, man. Because it means that the deployment process has been made quite iffy, and you know, like it's not really idempotent. So if I just go to Golang here and I look at the what errors do you have? It's saying, right, let's see, the first one is okay, cool. It's either expecting I cool. So what we're gonna do, we need to edit alright, cool. I guess that's right. What we're gonna do, we're just gonna Helix. Cool, and we didn't have the alright, we're gonna so the first thing what I'm interested in is supposed to. Alright, let's just hop over that for a minute. Let's start off with number 89, which is okay, we're gonna have to do the return error on nil here. Just put a nil here, and then because it's saying that this return here is not accurate, so this would be an error. If we get an error message, we're gonna but we're still gonna need, because I'm still expecting a string. So here I'm just gonna put a string, and here I'm gonna put, tell me if do I have error? No, this is it's gonna be a string as well, isn't it, to be fair? If we're fair about it. Oh nah, but it's gonna be nil on the other side too. Ah, fuck it, errors there. Alright, there's error here, so I can use error. Type there, cool. Alright, next thing is, okay, these ones are declared but not used. So what I'm gonna do here, because I don't really need to use pod running, I'm just gonna take these and put them in the yeah. Okay, there we go. Status message declared and not used. Cool. Status message is gonna be the dashboard section. It's gonna say else. Because it's not actually useful unless it's being used for debugging, to be frankly honest. So I'm going to put that here. We don't really want a message, because you have to pause this as well, which can get pretty iffy. Now the init function method is a bit weird, because that's complicated. That's like some wait a minute. Why? Oh, okay, yeah, my bad. This is meant to be just tr. transport is there. Alright, cool, that's fine. TR should work well there, and I believe that's it. But then now we're gonna need to get this uploaded again, which can get iffy. How are we gonna do this? Because again, like I said, the script is not idempotent. So what I'm gonna need to do is gcloud. I'm gonna need to ultimately delete the bucket. Only I can remember the name of the bucket. Actually, yeah, I can, which is where's the name of the bucket? God dang, monitor test, man. Monitor test 55909322908. Oh, what we're just doing rm-r. Cool. All right, let's get back to these errors that we had. Oh nah. All right, cool. Normally, if I was like, if this was production, I would be heavily invested in like make files that make the development process much more quicker. So I'm just gonna rm this file here, and then I'm also gonna just look, if I do upload, it should just do the upload, and that's all that should pretty much happen. Okay, because the terraform didn't run properly. We didn't get to this section, so I should be able to just do make deploy all again. Creates the bucket again. Uploads. Fresh and state, and so this is what wasn't actually taken care of here. So alright, so it was just a cloud function. Sometimes it gets iffy as well, because it actually yeah, but then okay, now I know what else is gonna, and then the build triggers build again. So that's the only thing that didn't actually build correctly. So if I go here, what I'm gonna need to do, I'm gonna need to go to cloud functions, and so even though that build occurred, like I don't really like these functions a lot, because I could have put the cloud function in actually Kubernetes, which would have made it much more simpler. Okay, here, so this is the cloud function. I'm just gonna delete this. See here, I was testing it, like I've never really. Alright, so but yeah, I should show what happens when it's thingy, but yeah, that's pretty much that. Delete and I'm ultimately aiming to have this video like maximum 40 minutes or so, so I might have to do some edits there, but again, let's see. So here we're gonna just Cool. All right, so it's gonna start doing the deployment again. This one should be more successful this time from my perspective of things. Since we've modified the function, we've uploaded the function again, which is some code that we actually go over. So okay, all right. Well, if we look here, we can see there's definitely a bunch of stuff there. No, if I cd into that directory and I do tree once more, you see we're just gonna ignore a lot of these because I just like disabled a lot of these. So like for example in the sock shop charts also I'm using Helm, and so I'm using Helm to deploy the charts. I need a tiller. I can't really go into too much detail as to why I need a tiller there, but I have a tiller, and yeah, pretty much. I think the most important thing to understand here, because these charts are pretty simple, you can just go to the sock shop and look at them, or you can look at the repository online later. Well, I think what's important here is the cloud build, right? So we build and import Docker containers. We'll speak about the Go code in a minute, and we'll look at the cloud build as well, and the rest of it will be sort of self-explanatory.